Find y and z parameters for the network shown in the figure. So first key point is I will find out the y parameters here because circuit is in a delta form. In this case, I have calculated z parameters first because circuit was connected like a star connection. Here don't calculate y parameters for this. It takes too much of time. So let us calculate z parameters for this circuit because it is connected in star fashion. Simply apply the KVL for mesh 1, mesh 2 and compare and you will get the z parameters. Use the relation to calculate the y parameters. So then do not do the reverse process for this. Do not calculate y parameters for the circuit. It takes too much time. Similarly, I will find out y parameters first for this network because it is in delta form. Don't find out z parameters for this. Use the relation to reduce the time. It doesn't mean that you don't get the values. You will get, but time consumption will be more. So that I will calculate the first the y parameters. So here the current I1 is flowing. Here current I2 is flowing. These two are not given. You have to write it down. So first I will done. Here it is node 1. Here it is node 2. So apply KCL at node 1. At node 1, 3 branches are connected. 1, 2, 3. Assume that these two currents are outgoing. Incoming currents are equals to outgoing currents. So that I will take a positive sign for the outgoing currents and negative sign for the incoming currents. So that minus I1 plus current flowing through this branch is V1 divided by a 2 plus current flowing through this branch is total voltage is sum of these three voltages. Voltage at this node, voltage at this node, and this voltage should be considered here. So that the total voltage of this branch I will write here with reference to this V1. With reference to V1, so that V1 minus of 3 into V1 minus of V2 divided by total resistance of this branch is 1 ohm, that is equals to 0. Then do simplify this. I1 equals to V1 divided by 2 plus V1 minus 3V1 minus V2. I1 equals to, so 1 plus 3, here it is minus 2, V1 divided by 2 minus 2 into V1 minus V2. Alright, so V1 1 by 2 minus 2, is that minus 1.5? 2 minus half, it is 1.5, but it is minus. So that minus 1.5 minus V2. So that write it in standard form. I1 equals to minus 1.5 into V1 minus V2. Call this as equation number 1. Alright. Let us apply KCL at node 1, node 2. Okay. So it is incoming. Assume that these two currents are outgoing. So one incoming currents, two outgoing currents. I will take minus sign for the incoming currents and plus a sign for the outgoing currents. The total current of this branch equals to V2 minus 0 divided by 1. So that it is V2 by 1. Then a total voltage of this branch is because of three voltages. One at node 2, one at node 1, and because of this voltage. So that with reference to V2 minus of, here which is coming first here, it is negative sign. So that minus 3 into V1 and minus V1 divided by total resistance of this branch is 1, that should be equals to 0. Then do simplify this. I2 equals to V2 plus V2 plus 3 into V1 minus V1. Alright, then I2 equals to, it is what here, plus 2 into V1. Next is what here, plus 2 into V2. Call this as equation number 2. Have you understood till equation number 2? Have you understood till equation number 2? Just we have applied KCL at node 1 and KCL at node 2. Correct me or stop me if I am doing any mathematical mistakes. Good. Now let us compare this equation with the standard equation. What is that standard equation? I1 equals to, let us compare equation number 1 with I1 equals to y11 into V1 plus y12 into V2. Let us compare this equation number 2 with I2 equals to y21 into V1 plus y22 into V2. After comparison, I will get y11 equals to minus 1.5, y12 equals to minus 1, y21 equals to 2, y22 equals to 2. So unit is mho or Siemens. Okay, then I will write all these equations in matrix form: minus 1.5, minus 1, 2 and 2. Let us calculate determinant of y. Minus 1.5 into 2, it is minus 3. Minus into minus, it is plus. 2 into 1, it is 2. So determinant of y is here minus 1. Next, let us calculate Z11. Z11 equals to y22 divided by a determinant of y. What is y22? It is 2 divided by minus 1, that is equals to minus 2. What is y12? Y12 equals to minus y21 divided by delta of y. What is y21? Y21 equals to, it is plus 2 divided by delta of y is minus 1, that is equals to 2 ohm. What is y21? Minus y of 1 2 divided by delta of y, minus of, what is y12? Here it is minus 1. Minus into minus, here it is plus 1 divided by minus 1. Here it is minus 1 ohm. What is Z22? Z22 equals to y11 divided by a delta of y. What is y11? Minus 1.5 divided by delta of y is minus 1. Here it is equals to plus 1.5 ohm.